Okay, the slide shown here indicate the distance matrix or proximity matrix that indicate the distance between one document to the other document. Okay, so given the distance of each of the document from the document and also the cluster here, cluster 1, cluster 2, and cluster 3. So we are asked to merge two clusters by using a single link and also complete link. So single link refer to the shortest distance between two documents belong to two different clusters. And the complete link refer to the largest distance between two documents that belong to two different clusters. So let's assume we have this cluster. So the issue that we want to address here is whether we want to combine these two, or these two, or these two. Okay. In the first question, they ask us to use single link, which means that the shortest distance between two documents belong to two different clusters. So for us to find out which one we want to do the merging, whether the cluster 1, this is cluster 1 and cluster 2, or cluster 1 and cluster 3, or cluster 2 and 3. Okay. So we need to know what is the reason for this. Okay. So we go back to the information provided to us here. So what we can say that, okay, single lines minimum distance. So we want to find the minimum, but before that we need to know which cluster belong to what. So this is 1, 2, 3, 5. So that means we have 1, 3, 5, and 9. Okay. So we need to find the shortest distance, not to their own cluster, not on this one, not on. Let me redo that one. So we don't want to get this one and 3 and 5 and then 9. And then similar to D3, we don't want to use this. And D5 and D9. And D5 also, we don't want to have this and this. Okay. Okay, so for D1, first we start with D1. So we find the minimum distance. So the minimum distance to the other. Okay, but before that we have to do some coloring first. So this one is, because the second cluster here is this 1, 8, and 10. Okay, so for these two distance to merge, we need to find the shortest distance. So the shortest distance will be covering all of this. This. So this is a simple task, but you need to be aware which one you want to pick to be the smallest one. Okay. And then over here we have D7. Oh, that one is belong to the other cluster, so we don't need to include that. Okay, so we have this one. So red going to the blue one. So the shortest one will be this. Highlight this. So the shortest one between between cluster 1 and cluster 2 would be between document 1 and 2. So document 1 and 2, when we so basically the document 1 and 2 here. So this is the shortest distance between between cluster 1 and 2, which is the value is 1. Okay. So now we need to determine what is the shortest distance between document 1 and 3. Yes. So how do we do that? We go back to here again. So now we will do different color. Let's suppose we use gold. So now cluster 3, we have 3, 4, 7. So 3, 4, 7, we use this and this and this. So basically we are choosing document 2, 4, 6, 7, 4, 6, 7. So this is not 4, 6, 7. Okay. So 4, 6, 7, we are looking at this value and this value and this value and this value. Okay. So basically for document 1, for cluster 1 to cluster 3, the smallest one will be 1.7. Okay, 1.7 is the smallest one. So that means 1 to 7. This is 1 to. Yes, no. Document 3 should be document 3. So just now is 1 and 2. Distance is 1, and this is 3 and 7, which is 1.7. So how do I get this? 1.7 is from here. Because the yellow one is your third cluster. So the third cluster going to the first cluster. So meaning that the yellow going to the red one. So the smallest one is this one. Okay, so that is between 3 and 7. The distance is 1.7. Okay, so we get that result. Now we want to determine what is the distance between these two clusters. So this is cluster 1, 2, and 3. So what is the distance between these two? Okay. So for that cluster, we use purple. So basically, it's the two. Two. It's between the blue and the green. The blue and the green. So now let's suppose we start all over again. So now we want to determine the distance between these two. So now we are picking 2, 8 and 10. And then so that means we are looking for this. And then looking for this value. Okay. Then the cluster 3 is here. So cluster 3 is this one, not 4. 4, 6, 7. 4, 6, 7. So we are looking for this values. 4, 6, 7. Okay. So what about 8 and 2? So that is equivalent to 4 and 8 here. This is D4. This is D2, D6, D2, D7. And then we have over here again. So D add to D4. And then D add to D6. And then D add to D7. And then similar to here. Okay. But this value can be obtained here, which is document add to document 4 and 6 and so on. So this is document 4 to 8 and then document 8 to document 6 and document 7. So document 8 to document 7 here, which is this one. So basically this is the mirror of this one, this value. So for this one, we are looking for this value. Document 10 and document 7, document 10 and document 6 and 4. Okay. So based on the intersection here, the smallest one will be which one is the smallest one? 2.4. No. Yes, 2.4 is the smallest one. Because over here, nothing. So 2.4 is the smallest one. So the distance between this is between 4 and 8. 4 and 8. So this is the distance. 2.4. Okay. So when we redraw this one, so basically these are the distance 3 and 4. Let me see. 3 and 7. 3 and 7. 3 and 4. Yeah, this is the smallest one. In the previous one, it should be 1.1. So basically, this is the shortest one. 3 to 4, which is 1.1. Okay. So based on this information, so we can tell that these two cluster must be merge because they have the smallest distance between two clusters. This is based on the single link distance. Okay. So this is the solution for single link. Okay, now the other way around, because we have to be careful in which distance we are using now. Okay, that's all. Okay. So let's use coloring here. So easier to differentiate. So we have 1, 3, 5, 7. So this is red. And then we also have, oh, this is red also. And cluster 2, we have 2, 8, 2, 8, 10. And this is 2, 8, 10. And then cluster B, we have 4, 4, 6, 7. I think mistake already 1, 2, 3, 9. So this is the red. The 7 is the third cluster. 4, 6. Four, 6, 7. Okay. So this one also maybe we could this one's supposed to be symmetric. So this one is 3, 10, and 2, 3.1 and so on. Okay. So you just fill in the blank space here with the symmetric value here. So now we want to find the maximum value between, so let's do it using this one. So what we want to do here is that, okay, first is between 1 and cluster 1 and 2. So we can do one by one, like 5 and 2. What is the distance? So 5 and 2 will be 5.6. So 5.6. And then we say 2 to 8, 5 to 8. So 5 to 8 is 5 to 8 will be 3.7. So must be be careful. And then 5 to 8, what is the distance? 5 to 8, 5 to 10, this is 4.1. So we will repeat this one for 1 to the other, and then we can find the maximum value. Okay, so if we go back to here, So when we compare cluster 1 and cluster 2, so basically we are looking at this D1 and this, and then D3 to this, and then D8 going to no D5 going to blue, and then D9 going to blue. But if the other way around is so the distance between 8 and 4, no, between 8 and 4 is this one. So this one is from cluster 1 to cluster 2. The other way around will be cluster 2 to cluster 1. So cluster 2 to cluster 1, or 2 to 1, 2 to 1. And then we have 2 to 3, 2 to 3. We don't have, but we have this one. And then we have 2 to 5, which is 5 to 2, this one. And then 2 to 9, 9 to 2. Okay. And also we have 10 to 1. 10 to 1 is already here. And then 10 to 3, 10 to 3 already here. 10 to 5 already here, and so on. And we also have 8 to 2. 8 to 2 is here. D1 to. Okay. And also 8 to. No, we don't go to 8 to 2. Sorry. Okay. So we are going from 8 to 1 already. 8 to 3, 8 to 5, 8 to 9, which is 9 to 8. 8 to 9, 9 to 8. 9 to 8 is here. Okay. So from all the circle one, we pick the maximum value. What is the maximum value? Okay. Double check again. So we go to from 1 to 2, 1 to 2 already, 1 to 10, and 1 to 8. And then we have 3 to 2. 3 to 2 is here. And then 3 to 10, 3 to 10 is here. And then 3 to 8 is here. And then 5 to 2, 5 to 2, we don't have here, but we have 2 to 5, which is 2 to 5 here. 2 to 5. So next one is 5 to 10. 5 to 10 is here. And then 5 to 8 is here. And next one is 9 to 2, which is 2 to 9. 9 to 10, 9 to 10 is here. And then 9 to 8 is, which is 8 to 9. 9 to 8 here. Okay. So basically we cover everything. So the maximum value would be, what is the maximum value? 6.6, right? Okay. So we can tell that for the maximum, for the complete link, the maximum value would be 6.6. So that is between 2 and 3. So 2 and 3, 6.6. Okay. So you do the same thing for 1 and 3. Okay, let's start all over again. So now we're going from 1 to 3. So we start with 1, 2, 4, 6, 7. 1, 4, 6, 7. This. Okay. And then 3, 4, 6, 7. So 3, 4, 6, 7. And then we have 5 going to 4, 6, 7. Okay, 5 going to 4, but actually it's 4 going to 5, which is here. So 5 going to 4, and then 5 going to 6, and 7. Okay, next one is 9 going to 4, which is 9 going to 4, which is 4 going to 9, which is here. And then 9 going to 6, 9 going to 6, we don't have here, but we can get 6 going to 9. Okay. And also we have 9 to 7, we put 7 to 9. Okay, so all these are the values that we have. So the largest value would be 8.1. This is between D4 and D9. So D4 and D9, so this is 8.4. 8.1. Okay. Last one is between 2 and 3. So between 2 and 3, let's erase everything. Okay. So now we are going from 2 to 3. So now we start with 2 first. So 2 going to 4, 6, 7. 2 going to 4, 6, 7. And then 10 going to 4, 6, 7. But we don't have here. So we go to 4 to 10. 10, 6, 7. And then we go from 8 to 4, 6, 7. Okay. So that's all we get. 4 going to 2, we have. Okay. So the largest value would be 8.3, which is this one. So the distance will be here is 8.3. So we can assume that the distance between the cluster here obtained is using the maximum distance between two documents belong to two different clusters. But to decide which merging should we do, we should choose the smallest one here. The maximum distance is determined between two clusters, but when it's come to merging, we need to choose the smallest one. So cluster 1 and cluster 2 will be merged. Okay, so in the final exam or in midterm, you get marks if you can tell that what is the maximum distance between, what is the complete link distance between all the cluster that we have. So similar to the single link, so you need to decide what is the minimum distance between one cluster to the other cluster. Then you get marks. If you don't get marks, if you did not specify between what document and then what is the distance, then you lose mark there. Okay. Some students say, okay, based on this table, we merge. If you use complete link, we will combine cluster 1 and cluster 2. So that is only the final answer, but you didn't show how you get to that point. So you need to show how do you get to that conclusion. What is the distance between those cluster and why you choose cluster 1 and cluster 2 should be combined. Okay. Any question? Okay. And of course, if they ask you to find cluster that we should be joining here. Okay. So that means we based on the centroid, if we use the centroid in a small, so that means we need to find what is the center of each of the cluster here. Okay, so since we have 4 documents here, and of course we have the term document matrix, so we can find what is the center here by taking the average of all the vector value that we have for all the document in that particular cluster. So this one is easy. So once we get the center, then we can find the distance using the Euclidean distance that we have. So this is based on centroid. We just get the center of the cluster by taking the average of all the members in that particular cluster, and then we use Euclidean distance to compute the distance. If the question asks you to determine which cluster should be combined using average link, then you need to compute the average link for 2 clusters, for example, like this. So how do you find the average? So basically you add up all the distance and then you take the average. So basically you do this one. Okay, this is the 3 distance, and then do again for the rest. So once you get all the distance here, then you take the average. Okay. So this is the average link where you take the average distance between all the members that we have. But if they ask you to use single, that means you need to determine which 2 documents are nearer to each other coming from 2 different clusters that we have. Okay. So you really need to look into this, because this one in the final exam most students cannot answer because it involves a lot of calculation. Any question?